Good afternoon, everyone. I am back on my lunch hour, so I figured I would spend it doing a bit of studying and recording another lab here. Today we've got Jeremy IT Lab's Day 27 OSPF lab packet. This is the third or fourth in a series of OSPF videos I'm doing. Been studying a lot of OSPF. I know it's important for the CCNA and for subsequent certifications and just in general. But I would be lying if I said I wasn't a little excited about moving on past this. But I want to do all of the labs and just work my way through them and really get this information down and make sure that I can hook this stuff up correctly, just to be as prepared as possible for the test. So let's just go ahead and get started. I'll try to get through this in the next 35-40 minutes or so, and hopefully we can get some pings flowing through this using the dynamic routing protocol known as Open Shortest Path First. All right, so configure the appropriate host names and IP addresses on each device. Enable the router interfaces. You don't have to configure ISPR1, ISPR being over there. All right, so let's just start here at router 1. Let me move this over a bit so you can see CLI. All right, so conf t. And we are first of all going to configure the host name. So the host name for this is going to be router 1. All right, and then it's got three interfaces, the G30, the F10, and the G00. So let's go ahead and do the interface G30. So interface gigabit 30. And that's going to have IP address 203.0.113.1, and that's a /30, 255.255.255.252. And I'll say no shut. All right, it's changed to up. And then we will move on to interface. Let's do G00. So interface gigabit 00. And that's going to be 10.0, IP address 10.0.12.1 on a 255.255.255.252. No shut. And then finally, interface fast Ethernet 10, IP address 10.0.13.1 on a 255.255.255.252. No shut. All right, so that's all of them. So this step 1 here, configure the appropriate host names and IP addresses on each device. All right, enable the router interfaces, which we did. So that's all for 1. Router 1, now let's do router 2. CLI, return to get started. conf t. So first things first, host name is going to be router 2. And we'll go to the interface gigabit 00, IP address 10.0.12. What is it? 255.255.255.252. And no shut. All right, that looks like it's converted to up. All right, then next, exit interface fast Ethernet 10, and that is 10.0. Wait, IP address. Yeah, right. 10.0.24.1. Is that right? Yes. 10.0.12.1 was the gigabit, 12.2, 12.1, 24.1 is the fast Ethernet. 252, that's a /30, no shut. All right, there's only 2 interfaces on router 2, so we're good there. Same thing, router 3. conf t. Host name is router 3. All right, and the first of all, the interface fast Ethernet 1/0 is going to be 10 IP address 10.0.13.2 255.255.255.252. No shut. All right, and then next F20. All right, so interface fast Ethernet 2.0 IP address 10.0.34.1 on a 255.255.255.252. No shut. All right, and that's it for router 3. And then finally router 4, which has 3 interfaces that need to be configured. All right, so en conf t. So first, let's do F20. So first of all, host name, router 4, interface fast Ethernet 2.0, IP address 10.0.34.2. That's a 255.255.255.252. No shut. All right, we got to do the F10. Interface fast Ethernet 1.0. IP address 10.0.24.2. Again, a /30. No shut. And then finally, this third G00. So interface gigabit 00. And that's going to have, well, it looks like 192 IP address 192.168.4.254 on a /24. So 255.255.255.0. And that's going to do no shut. All right, and then I think the next thing is the host. So the host needs 192.168.4.1. So let's go into the PC, config, Ethernet, what did I just say? 192.168.4.1. 192.168.4.1, and it's a /24, which is populated automatically. All right, so I think that's all. Oops, I didn't want to do that. That's all for step 1. We have given the host names and IP addresses on each device, enable the router interfaces. You don't have to do ISPR1. All right, good. So let's see. Configure a loopback interface on each router. All right, so we need loopback 1, 2, 3, and 4. Okay. So router 1. Exit. So we're going to say interface loopback 1. And that's going to be IP address 1.1.1.1, and it's a /32, so 255.255.255.255. So a single address. And we don't have to do no shut on those because they're up automatically. Router 1, so router 2 needs loopback 2. Interface loopback 2. IP address 2.2.2.2 0.0.0.0. No, that's wrong. 255.255. All right. Thank you for the error message. Router 3 needs loopback 3. Interface loopback 3. IP address 3.3.3.3, 255.255.255.255. And then finally, router 4 needs loopback 4. Interface loopback 4. IP address 4.4.4.4, 255.255.255.255. That's all done. Configure a loopback interface on each router. We did that, okay. Enable OSPF directly on each interface of the routers. Configure passive interfaces as appropriate. So starting on router 1, passive interface will be the G30, but we need OSPF turned on F10 and G00. And it says enable OSPF directly on each interface of the routers. So I'm thinking that means we don't do it at the router configuration level. We do it on the interfaces. So let me go ahead and try that on each interface of the routers. Okay, so let's see. Do show IP interface brief. So we've got 1, 2, 3, 4 interfaces that need to have OSPF manually or configured on. Let's try gigabit 00 first. So interface gigabit 00. And I think we want to say IP OSPF process ID 1 area 0 ABCD. I think this is like the network portion of it. So we got 10.0, 12.0, question mark, unrecognized command. Let me just see what this does. So maybe that's all we need. I should probably know this, how to configure OSPF directly on an interface, CCNA. Yeah, that's it. IP OSPF process ID area ID command for that interface. So that's all we have to do. Let's jump on to, that was gigabit 00. Let's do fast Ethernet 1.0. So interface fast Ethernet 1.0. And then IP OSPF 1 area 0. And let's do gigabit 3.0. So interface gigabit 3.0. IP OSPF 1 area 0. And for the loopback, I suppose we should do next. So interface loopback 1. And we're going to say IP OSPF 1 area 0. Now exit. All right, so we enabled OSPF directly on each of the routers, and we need to configure G30. Actually, I enabled it on G30, so I didn't actually want that. But regardless, now we go to router OSPF process ID 1, and in here we can set the passive interfaces. So we don't want hello packets sent, OSPF hello LSAs, advertisements sent out of the G30 interface to the ISPR1 router because it's not going to participate in OSPF with us. So what do we got here? Passive interface gigabit 3.0 should not be sending hello messages. All right, I believe that's it for router 1. Now, how can let's see, do show IP OSPF. So routing process OSPF 1 with ID supports this minimum, blah, blah, blah. All right, so it's on. Neighbors, none, no neighbors yet. All right, so let's go to router 2, and I think I will configure it on this one a slightly different way just to get some exercise with that. So instead of going directly onto the interfaces, first I'm going to do show IP interface brief. just so I have that in front of me. I like that. And then I want to do router OSPF process ID 1. So now we're in router configuration, or like global OSPF configuration mode. And with this, we can use the network command, and we could say 10.0.12.0 and then 0.0.0.3 to capture the 252 subnet area 0. All right, so that's 10.0.12 to capture for the gigabit. The next is network. We can see that a neighbor connection was made with the previous router that we just configured, router 1. Network 10.0.24.0, and that's a 0.0.0.3. So this is just the opposite wildcard mask of the subnet masks that we configured for the actual interface. All right, so 10.0.24.0, and that's area 0. And then I guess loopback is something else so we should do. 2.2.2.2, maybe I want to say 2.0. I'm not really sure actually. And then this is 0.0.0.0. I think that's maybe correct. All right, so that is done. Now let's see, exit, do show IP OSPF neighbors. So there's one full neighbor connection currently made. All right, so that is that. That's OSPF enabled on each interface of the routers, and passive interfaces. No passive interfaces here. Number 3, same thing. There should be no passive interfaces. So exit. I'm going to say router OSPF process ID 1. Do show IP interface brief. So we need to do 3 of these. So network 10.0.13.0 0.0.0.3 area 0. Network 10.0.34.0 0.0.0.3 area 0. And then network 3.3.3.3 0.0.0.0 area 0. I'm not really sure about the loopback configuration there, if it needs to be wider than that or if it should be as specific as it is. Since we did, I'm always used to just doing the mirror image of the subnet mask, and in this case for the loopback addresses we used a full /32 subnet mask, and that would imply that we need to do the full opposite wildcard mask, which would be 0000, but that's very specific. I'm not sure how that will work. All right, so we did that, and then finally router 4. All right, so first things first, for router 4, again, G00, because it's talking to a switch, does not need to send the hello packets, so we will immediately go and OSPF process ID 1. We're going to say passive interface gigabit 00 so that it doesn't send hello packets, and that's correct. 00, yes. All right, and on this one, I'll go ahead and maybe just go right into the things again. So F10, exit, interface, fast Ethernet 10, IP OSPF, process ID 1, area 0. All right, I think that's that for that one. And then for F20, exit, interface. All right, and a neighbor relationship was made, so we know that worked. Interface, fast Ethernet 20, IP OSPF, process ID, no, wait, process ID is 1, area 0. All right, so I would expect those neighbor relationships to all come up. All right, and now, so if we go back to router 1 and we say Do show IP OSPF neighbors. We've got some neighbor relationships. So that seems to be configured as we'd expect. It's got neighbor relationships with 2222 and 3333. So with router 2 and router 3, which makes total sense. All right, and let's just confirm router 4 should have relationships with router 2 and router 3. So if we say do show IP OSPF neighbors, I'm liking using these shorthand commands more. It's a little bit faster. And look, with 2 and 3, we've got neighbors. All right, so I think that's configured all correctly. Configure the reference bandwidth on each router so that the fast Ethernet interface has a cost of 100. So the default cost of fast Ethernet is 100, but the default reference bandwidth is 100. And so in order for fast Ethernet to have a cost of 100 after the calculation, it needs to be 10,000 divided by 100, which is 100. Is that correct? Remedial math. 10,000 divided by 100 should be 100. All right, so that means we need to set the reference bandwidth on each router to 10,000, presuming it's in megabits, I think. I think that's right. All right, so how do we set reference bandwidth? I think we're in router configuration. I know that. So it's auto cost. Yes. Auto cost, reference bandwidth, and then what is it in? In megabits. So 10,000 megabits per second, which is a reference bandwidth. If we change it to 10,000, and then we do divide by the default speed of fast Ethernet, which is 100, the result is 100. And that means the cost for fast Ethernet becomes 100. So I think this is what we want. So we'll do router 1, ensure that it's the same across all routers. All right, so same thing for router 2. Let's see, router OSPF, process ID 1, then auto cost, reference bandwidth, 10,000. And next up, router 3. Okay, so auto cost, reference bandwidth 10,000. And then finally, router 4. Not on the interface, so we need to say router OSPF process ID 1, auto cost, reference bandwidth 10,000. All right, that's all of them. Now, can we confirm that the cost of fast Ethernet interfaces are 100? So let me go to router 1. Actually, this, let's see. Do show IP OSPF, maybe interfaces? Okay, we have that. So we can look at OSPF interfaces, process ID 1, router ID, and look, cost is 100, and fast Ethernet cost is 100. Now I'm just curious, what is gigabit cost? So let's look at router 1. Do show IP OSPF interfaces. Gigabit cost is now 10. That makes sense, and fast Ethernet is 100. So this OSPF should theoretically take the path of any gigabit line or segment before an fast Ethernet segment. I think we are done with that part. Okay. Configure R1 as an ASBR that advertises a default route into the OSPF domain. So that's going to require another little special command. Let me get out of that. Configuring the router, that's what we want to be. And I think we want this default information originate. So we'll say default information, question mark, originate, tab, question mark, nothing. All right, so this is going to say, okay, you're going to send the default route. Now, there should be no route yet. I'm going to create it now. I'm going to say IP route, question mark. And this is default route, so that's going to be o.o.o.o, o.o.o.o.o. and it needs a next hop address. And so that, I believe, is going to be the ISPR's G00.2 interface. So 203.0.113.2. So let's do 203.0.113.2. Anything else? I think that's it. I don't need to configure a metric, I don't believe. All right, so I think that is done for configuring router 1. All right, now check the routing tables of router 4. What default routes were added? Watch the video for a brief explanation. So let's see here. Do show IP route. Check the routing table. And what do we have? All right, so we've got routes to the various loopback addresses learned by OSPF, routes to router 1, router 2, and router 3, and router 4 that's directly connected. Okay, not learned by OSPF, got it. We've got paths learned by OSPF to the 10.0 subnets, so 10.0.12 via 10.0.24.1, etc. We've got another one to the 203.0.113, so up to here, learned by OSPF. And then this, I think, is what they're calling out, E2. E2 is an OSPF external type 2. So that's like, I believe, an external route learned via OSPF via 10.0.24.1. So it's saying, okay, from myself, I need to travel up to 10.0.24.1 to get out here eventually to the internet. And notice it shows the path that includes a gigabit segment because it's going to have a lower cost versus the two fast Ethernet segments that would add up to 200 basically. All right. Very interesting. Okay, so I think that's pretty much the heart of the lab. We've got the segments, the OSPF being shared, the routes all being shared. Let me just confirm that I can, for example, from here, ping router 1, 10.0.13.1. So let's try that. Do ping 10.0.13.1. And that is successful. Let me see if I can ping the ISPR now. Ping 203.0.113.2. And let's see what happens with that. Okay, that is successful. All right, so there is connectivity throughout the network, throughout the area, and to the, I guess, external points outside the network or something. Maybe there's a better way to say that. Okay. Final task, use simulation mode to view the OSPF hello messages being sent by the routers. What fields are in the hello messages? All right, so simulation mode. Let's play. All right, so there is a packet, or presumably a hello message. So let's do a few of these. And with simulation mode, you can fast forward through time. All right, and so let's say, we've got this message here. I paused it. Now if we double click into this, and what do we see in here? So at device, source, destination, that's the multicast address for hello messages. The frame's destination MAC address, PDU. All right, so the destination IP address is a broadcast or multicast address. The device dispatches the packet. The device receives an OSPF packet. The OSPF packet is a hello packet. The hello packet is from an existing neighbor. The device resets the timers for this neighbor. So that's pretty interesting. You can do some cool stuff in here. If you want to study the IP header, the Ethernet header, all of this stuff, you kind of have to know. I expect to have to know the sizes it shows you. Which is helpful because there's a ton of questions in the flashcards for Jeremy IT Labs course. It's about, I shouldn't say a ton, but there are questions about the size of the various headers. And you can see what's in that OSPF hello packet. OSPF version 2, type 1, which is a hello LSA, packet length, router ID, area ID, checksum, blah, 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 network mask. Hello interval is 10, which is the default. That's something we have to know. Router dead interval is 40, also need to know. BDR, DR, and the neighbor. So cool stuff here that you can mess around with. And one thing I wanted to point out also is that you can use this challenge me, which you can just basically study for the CCNA right here inside of Packet Tracer. So what is the device decision at layer 1 to drop, queue, accept, transfer, or de-encapsulate? Removes a header. I don't think there's anything else to remove. It would be moves the PDU from an inbound OSI to the outbound OSI. I don't know about that. Accept and finish the processing. I'm going to say accept and see what that does. It did not. What hint? Receives the frame. Okay. I don't know how to see if I actually got the correct. Sorry, that is not right. Please try again. What is the device decision? Okay, let's see what it is. Maybe it is to drop it. Not either of those. De-encapsulate. Oh, it looks like de-encapsulate was correct. Anyway, so that's kind of interesting that you can get that information. And if you let it play out, I don't know how fast this actually goes, but the hello messages get sent every 10 seconds by default between the neighbors to say, hey, are you still here? Are we still neighbors, etc. So that's kind of interesting. Use simulation mode to review the OSPF hello messages being sent by the routers. What fields are included? Now, I want to pause that. I assume these are ARP. What is this? Multicast. Am I like stuck on this thing? I don't know. Oh, STP. What is that? What is that? It's not Stone Temple Pilots. I can't remember. I should know this for the switches. What does STP stand for in networking? Spanning Tree Protocol. Oh my gosh, I should have known that. Anyway, yeah, so Spanning Tree Protocol. What are those types of messages called? Root Bridge. Spanning Tree. Spanning Tree Protocol, what does it be like? Yeah, checking for STP messages are always being transmitted to every device in the network to constantly check for topology changes. BDUs, bridge protocol data units. Yeah, I need to review all this. Anyway, okay, that's it. That's it for the lab. So we have this. There's going to be a day 3 OSPF lab and one more from the Cisco CCNA in 60 Days book that I've been following through. And so I'll get those 2 done, and then we'll be ready to move on to, I think, DHCP, but I'm not really sure. It's something after routing. So that is all. I hope everyone has a nice lunch hour, a good day, good rest of the week, and I will talk to you all later. Thank you.